All right. There we go. We're recording. Are we? Yeah, we are. We're going to do exponent rules today. In total, we're going to do 3. But because there's not a lot of people today, we're just going to do the first 2, which are pretty straightforward. If you look over here, those are all the in your high school career. We're just going to do first 3. That's it. We're going to do first 3. We're going to talk about the 4th one, but it's kind of an unofficial rule. All right, so we're going to look at this first one. We have a bunch of examples. We have essentially a multiplication between powers. What do you notice about the powers that are in the examples here? What do you notice between the ones that are being multiplied? Like, for example, this one. They what? Same base. Same base. And that's a very important thing because this rule only works if you have the same base. Otherwise, you can't apply it. You can't apply it. So just to kind of derive the rule, we're just going to rewrite the exponent form, and we're going to write it in the expanded form. So 3 to the power 2 would be the same as 3 times 3. And then 3 to the power 4 is the same as 3 times 3 times 3 times 3. But if you kind of look at it overall, this is just one big expanded form. You have a bunch of 3's being multiplied. Yes, we have brackets around, but this is really just a multiplication. We could even rewrite it just as 3 times 3 times 3. Is that all of them? No, one more. There we go. So how many 3's do we have multiplied? 6, yeah. So 6 3's, and that's why we can write it as a single power 3 to the power of 6. Do you see a shortcut? Because this writing out this expanded form is pretty long. So the shortcut is add the exponents. You don't even have to write the expanded form. I'm not going to ask you to write the expanded form to kind of simplify this. Just add the exponents. So in this case, they have the same base of 3, so all we have to do is take 2 plus 4, which is 6. Now we can write the other one, this next one in the expanded form. So it's going to be 4 times 4 times 4. That's the first one. And I'm not going to put brackets here, just so we can see it as an overall expansion. And then the last one is going to be also 4 times 4 times 4, which overall is 4 to the power of 6 as well. And a lot of questions is going to ask you to write it as a single power. You're going to have 2 powers multiplied. You're going to have to simplify and write it as a single power. You might have to solve it, but you might not have to. You might just have to write it as a single power. The next one, what do you think the answer is going to be? 6 to the power 4 times 6. Yeah. That's right. So this is actually 6 to the power 1. And I'll just write it a little bit like this. So 6 to the power of 4 plus 1, which is 6 to the power of 5. And I'm not going to write the expanded form here. We're going to take a shortcut. Now the next one, we have 3. The bases are the same. What would be the final answer? I'll write that process here. Yeah? 2 to the power of, okay, so we have 4 plus 2, 3, which is 2 to the power of, yeah. Yeah. Yep. The questions that I've seen like this are multiple choice, so you don't really have to show much. And we'll do some of those examples, so you don't really have to show much. The last one, it doesn't have a number as a base, it has a variable as a base, but the rule is still the same. We're going to take k and then just add up the exponents, which in this case is k to the power of 8. All right, so that is it. This, do you think this is going to work with fractions and negative numbers and any of that? Like, let's say we have 1 to the power of 2 times 3 over 4 to the power of 2. Could I do it here? Why not? No same base. So let's say I just rewrite it differently. Half power of 2 times 1/2 the power of 5. Let's say. Is that going to work? So what would that be? 1/2 to the power of 7. Yep. So the base is the same. We copy the base and then just add up the exponents. And that's it. The top one, what would we do with the top one? Yeah. No, no, we can't do that. Remember bed maths. What would you do first in bed maths? Yeah. Yeah, we're going to have to kind of write them in the expanded form and then multiply them and multiply it all the way through. So 1/2 is really 1/2 times 1/2. And then times 3 over 4 to the power of 2 is 3 over 4 times 3 over 4. And then we would just multiply everything through, all the numerators, all the denominators. So this is just one long multiplication, just because we have brackets. What would this be, actually, as a single fraction? You know, how'd you get that? And then you multiply them through. Okay, so you can also do it in the one shot. So you can do 1 times 1 times 3 times 3, which is 9. That's a full multiplication. And then you have 2 times 2 times 4 times 4, which is 64. And then you would go and reduce it. So that's how you actually can't write these as a single power. You have to just solve it. That's it. Negative numbers, same thing. I have a negative 3 to the power of 5 times negative 3 to the power of 6, let's say. That would be what? Negative 3 to the power of 11. Yes, we got up the exponent. It doesn't matter that it's a negative base. We just copy the base and add up the exponents. Any questions on this? No. This is called the product rule. And it just says when you're multiplying powers with the same base, you just add up the exponent. This is the form that we're writing here. Well, we're going to write that too. So if we have the same base to some exponent times a base to another exponent, all we have to do is add them up, add up the exponents. Don't add up the bases. That's one of the more common mistakes. Yeah, good. So that's the first rule. Now, what I'll do is I'll give you some time to try these questions. We'll pick them up, and we'll see what happens. There we go. All right, so first one says 3 to the power of 2 times 3 to the power of 3. How's a single base? What is that? Yeah? 3 to the power of 5. I'll just write the steps, I guess. 2 plus 3 with 3 to the power of 5. Usually we don't write that middle step, but just because we're doing the first one. The next one, 5 squared times 5 times 5 squared again. Yeah. 5 to the power of. All right, so I that middle step again, 2. So 2, and this is 5 to the power of 1. So we're going to have this 1 2, which is 5 to the power of 5. Next one. I'm not going to write the middle step anymore. Oops. We have 2 to the power of 7. Yeah, 4 plus 3. And then the next one. Yes, D. Nelly? 1/2 to the power of 5. Excellent. E. Yeah. 6.1 to the power of 6. Excellent. And last one. This one's a little weird. Weird looking. Yeah. I see. So what's happening between them here? Yeah, that's fine. That's good. 4 to the power 11. Just because this bracket is there, this is still multiplication. Sometimes you'll have brackets, maybe like 4 to the power of 6, 4 to the power of 5, something like that. So it's just written in a different form. Yeah. Well, 4 to the power of 5 is just 4 to the power of 5, right? Yeah. This is a different bracket. If you had, for example, something like this, say you start with 4 to the power of 6, and then you have 4 to the power of 2 times 4 to the power of 3. You can do the brackets and then kind of work with this outside one too. Yeah, you can do that. You can also just combine it into one because it's still multiplication. The brackets are there just to kind of separate the powers. They don't really have any significance other than that. Yeah. 4 to the power of 0? Yeah. 0, 1. Anything. But I think is the second last rule there. So even if you have a letter, so a lot of times you'll see a variable like x to the power of 0, that's also 1. Yeah, so you're going to encounter that later on. We don't really concern ourselves with that here, but yeah, maybe you might have mentioned it for sure. But I think, yeah, you're going to see that in grade 10. All right, any questions about this product rule? No, pretty straightforward. Quotient rule is the next one. Quotient rule is about division. We have powers divided by powers, or power divided by power. In this case, we have 5 to the power of 5 divided by 5 to the power of 3. We're going to do the expanded form again. So the top one would be 5 times 5 times 5 times 5 times 5 of them. And the bottom one is 3 5s multiplied. Now, when you have kind of a setup like this is essentially a fraction where you can start canceling things out. So this 5 cancels out with this 5. This 5 cancels out with this 5. This one with this. And what are you left with? 5 times 5, which is 5 to the power of 2. What would be the shortcut for this one? Just subtract the exponents. Yeah, so you can take 5 to the power of 5 minus 3 gives you 5 to the power of 2. Same rule goes to the next one as well. It's 7 to the power of 4 divided by 7. And remember that 7 is 7 to the power of 1. So we can write it as 7 to the power of 4 minus 1, which is 7 to the power of 2. Yep. It's fine. So let's get to we're on our second rule. All right. Okay, so we just went over quotient rule. I'll just review which with you guys quickly. We're talking about you are dividing first we wrote it out. So the first one is 5 multiplied, and then that's divided by 3 multiplied. And because it's kind of set up in a fraction, we can just start canceling between the top and bottom. So if you cancel between the top and the bottom, all we're left with is just half and half, which is 5 squared. And then we have some there is a shortcut where we use subtract the exponents. Instead of writing out the expanded form, we can just write it as 5 to the power of 5 minus 3, which is the exponent. And that is the quotient rule. So now we do it for the next one. If you have a division, like this case, 7 to the power of 4 over 7 to the power of 1. All you have to do is just copy the base, which is 7, and then 4 minus 1 is 1. And this is a single power. We're writing it as a single power, not a solid. So the next one. Ow. Oops. So yeah, we're doing the next one. That's the p to the power of 8 divided by p to the power of 5. How would I write that middle step? I'm not going to write the expanded form, but just that middle step. Okay. 8 minus 5, which is going to be p to the power of 8. And that's it. This also works for fractions. This also works for negative numbers, for decimals. It's the same rule. The most important part is you have to have the same base. If they don't have the same base, all these rules go out the window. All right. That's it. Those are the only 2 rules that we're going to do today. I will write the general rule, the same as the one over there, which is base to the power of some m exponent divided by base to the power of some n is base of m minus n. And now we get to do some complex examples. There we go. Usually you don't have these written just by themselves. You combine it with everything else. All right. Do you want some time to work on these and then we'll take them up? Yeah, sure, why not? All right, record this. All right, so 8 to the power of 7 divided 8 by 8 to the power of 5. What is the final answer? Yes. 8 to the power of 2, and you just did that by subtracting the exponent, 7.5. Perfect. I'm not going to write the middle step anymore. So 4 to the power of 7 divided by 4 divided by 4 to the power of 3. Yeah. Yeah, that's right. That's a 1. 7 minus 1 minus 3 is? Yeah. 4 to the power of 3. Perfect. Next one. Come on, someone else. Someone, yes. Negative 0.5 to the power of 3, yeah, because 6 minus 3, perfect. Now this one. This one is a combination. You have multiplication and you have division. What do you think the strategy would be here? Okay, so let's do that. We're going to add up the top one, so we're going to write it as a single up top, which is 3 over 4 to the power of 6 over 3 over 4 to the power of 5. And then we do what? Then we subtract the exponent, so 3 over 4 to the power of 1, which is just 3 over 4. Right? We don't have to write that exponent of 1. There you go, and that's essentially it. These are going to get more complex as we learn all the rules. On Monday, we're going to give you some more complex problems just to get deeper into it. And as we do some practice questions, you'll see some combinations of these rules. Now, here is some examples of EQAO questions. So look at them. Maybe I'll zoom in so you can see this better. If you'd like to copy them, you can copy them. So in the first one, it says, what goes into the square to complete the equation below? So you have something, you have an expression, 8 times x to the power 3 times something, and that equals 24x to the power of 12. What would be your strategy to kind of solve this? Yeah. Oh, I see. So you're kind of undoing things. Okay. So if you subtract 3 from 12, what would you get? So it has to be some kind of x to the power of 9. And then you divided 24 by 8, which gives you, so it has to be 8. And you check it then. So let's say I have 8x to the power of 3 times 3x to the power of 9. Well, 8 times 3 is 24. That's good. And then x to the power of 3 times x to the power of 9, I will just copy the x and add up the exponent. So 3 plus 9 is 12. And that works. So when you have a variable combined with a number, a coefficient in front, you can deal with them separately. So that exponent doesn't apply to 8. It just applies to x. So when you're multiplying the powers, you still add the exponents. What's that? Trial and error? Yeah, you can just kind of guess. You can do that too. Try a few examples. All right, next one, number 2. It's kind of the same setup. You're trying to find the exponent of this power here, so that once you simplify this into single power, it's equal to the x to the power of 12. So trial and error works. What are you going to have to do in the numerator here? What is the action? What rule are we using? What's it called? In the numerator only. In the numerator. Going to be product rule. So what are we going to do with exponents up there? So we're going to add up 2 exponents, and then we're going to have to subtract the bottom one from those 2 exponents and get 12. So is this exponent that we're looking for going to be a big number or a small number if we end up with 12? It's going to be a bigger number, yeah. So do you think it's going to be 3, like this b here? Probably not, because 3 plus 6 is 9, and then minus 2 is 7, so that one doesn't work. What about 4? Okay, so I check. 4 plus 6 is 10, minus 2 is 8. That's no good. What about 8? Oh, 8 works. 8 plus 6 is 14, minus 2 is 12. Yeah, this one works. And if we try 9, 9 is going to be too much, so it's no good. Yeah. Ah. So you could do the division first. So you can simplify this as x to the power of something, and then do this subtraction. Simplify this as a single power, which would be x to the power of 4. And now you're working with a simpler expression. Now we're looking for something that adds to 4 to give you 12, which is 8. We also did substitution. So essentially, you take the answers that are offered, you substitute them in here, and you see if it works or not. And then you eliminate the wrong answers. A lot of ways to solve this. Next one. So we have m here. If you can see the exponent, it's very similar to the questions that we just did, except it's written in a different way. So we have 6a to some exponent over 2a to the power 3. It has to be equal to 3a to the power 5. Okay. 15. Okay, so let's check it. What if I have 6a to the power 15 over 2a to the power 3? Okay, 6 divided by 2 is, it's 3, so that's good, good part. What do we do when we have division? We're going to subtract. So we're going to do 15 minus 3, which gives us, okay, so that one's too big. That one's too big. We don't divide the exponents. You just have to look at the rules. Yeah, you'll have to come back to it. So 15 doesn't work. We just scratch that one out. Yeah. 3 to 5 on the other side, and then see what makes it equal. So let's say, so it would be 6a to some power m over 2, and you're combining this to 3a to the power of 8. Yeah? Yep, which makes a to the power of 8, right? Yep. And then that means that this has to be a to the power of 8. Yeah, you can look at it that way too. It's kind of like solving equations. We'll get to that more. What you did there is you were trying to solve the equation. We'll talk about it in the next chapter more, but yeah, that's the right step. So 8 seems to be the answer. If you try and sub it in, so 6a to the power of 8 over 2a to the power of 3, it's going to be 3a to the power of 5, which is good stuff. That's it. We're done.